All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. I'm fascinated with trigonometry, and I have been since I was in high school. I love how you can apply it to geometry and to physics, and I also love the beautiful formulas that come with it. One of the formulas that we have is the sum of the cosine of the sum of two angles. From that, through basic manipulations, we can get the cosine of the difference of two angles, and then the sine of the sum of two angles, and then the sine of the difference of two angles. That you can see right here. And again, these are beautiful formulas, but you might notice that there's some symmetry in them. We can make use of the symmetry of those formulas in order to get some relations between the products of the angles, and I'm going to show you how to do that. Okay, I'm going to do an old math teacher's trick. I'm going to work this out for one of them, and then I'm going to leave the rest to you as an exercise. And so what I'm going to do, I'm going to take cosine of A minus B plus cosine of A plus B, and add these two formulas together. What you'll notice, right, is that both of the formulas have cosine of A, cosine of B with a plus sign, and so I'll have 2 cosine of A, cosine of B. And one formula has sine A, sine B with a plus sign, and the other with a minus sign, so they cancel out. Okay. Now, I'm interested in what happens to the product of cosine A times cosine B. So I solve for this. This will give me that cosine of A, cosine of B is equal to 1/2 cosine A minus B plus 1/2 cosine of A plus B. I can then have go very similar with the rest of them. I mean, look at it, it's obvious. You can go sine of A, sine of B is equal to 1/2 cosine of A minus B minus 1/2 cosine of A plus B. And finally, sine of A cosine of B is equal to 1/2 sine A minus B plus 1/2 sine of A plus B. All right, now I've arranged them here to kind of help you remember them because what do we have here? Well, I've put the difference between the angles at the first in each of these terms. Everything has a coefficient of 1/2 on it. When both of the trig functions are the same, it's cosine. When there is a difference between the trig functions, a sine and a cosine, well, it's sine. Anyway, from there you should be able to remember it pretty well. Having done this, go out and actually take a piece of paper and work this out for yourself. It'll help in the memory of it. But I'm going to give you another thing to help you in the memory of it when I do an application. Okay, so I promised you an application, and all right, here's the confession. This application will mean a lot more to you if you're currently in or have had Calculus 2, because we're going to talk about how to use this to aid in the integration of trigonometric functions. So let's consider the integral of cosine of 3x times the sine of 4x dx. Well, so what I want to do here is and this is when I teach calculus, is I try to teach you a way that's more sensible to help you organize your work. And we don't have to carry along all of the integration apparatus. Let's take the integrand and work with it to transform it to something we can integrate. And so here I'm going to write this as sine of 4x times cosine of 3x, because this is the form my formula is in. So what is it? Okay, we have different trig functions, so it's in sine, and so it'll be 1/2 of the sine of the difference of these two angles, which is the sine of 4x minus 3x, which is just sine of x, plus 1/2 the sine of the sum of the two angles, which is 7x. And so this is something I can integrate. Okay, you can say that my original integral then will be I equal to the integral of 1/2 of sine x plus 1/2 of sine 7x. And this is just something that you can do quite easily. With a fresh piece of paper, I want to show you something that's not quite so simple. With the integral of cosine to the 4th x dx, because sometimes you need to put in an example that's hard enough where the student has to see the wheels turn. I'm going to raise cosine to the 4th power, but I'm going to do it in stages, not all at once. Cosine squared of x is equal to cosine of x times cosine of x. And this will be, okay, remember the first one is the difference of the angles. So x minus x is 0, cosine of 0 is 1, so it'll be 1/2 times 1 plus 1/2 times cosine of 2x. Okay? Now, cosine cubed of x, I'll take cosine of x times cosine squared of x. This will be, okay, 1/2 cosine of x plus 1/2 cosine of x cosine of 2x. Okay, this again 1/2 cosine of x. I don't have to fiddle with that, but I have this product here to take care of. Now, I've got the 1/2. To save myself some writing, note I'm going to be turning this product into a sum of two cosine angles. Each one of those terms will have a 1/2 in it. So 1/2 times 1/2 is 1/4. And now the cosine of x minus 2x. Well, cosine's an even function, so I can take the difference in either order. It's easier to take it 2x minus x, so this will be the cosine of x, and then plus the cosine of the sum of x plus 2x, that's 3x. Okay. And so I'll have, okay, my cosine terms in here I add together their coefficients, 1/2 plus 1/4 times cosine of x plus 1/4 cosine 3x, okay, and 1/2 plus 1/4 is 3/4 cosine x plus 1/4, okay, cosine 3x. All right, now cosine to the 4th power of x. Well, I'm going to be taking cosine times cosine cubed. So I'll have 3/4 cosine x times cosine x plus 1/4 cosine x times cosine 3x. Okay, and again, I'll have a 1/2 that'll come out. This will be 3/8 times 1 plus cosine 2x. Okay, and I'll have a 1/2 that will come out here, so this will be 1/8 times, okay, cosine 2x plus cosine 4x. Okay, now very carefully bringing these together, let's see. I'll have 3/8 because I only have a 1 here. Then I always make a mistake when I do the next term, so I'm going to be careful with it. I will have 3/8 plus 1/8 times cosine 2x, and then I will have 1/8 times cosine 4x, and so this is 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. And then this is a quantity that can be integrated pretty easily. Yeah, who is it? No, I'm not doing anything. Come on in.